Alright, here we go for part 2. When I take a function and I put it into another function, this is f of g, so when I take g and I plug it into the f function, any issues that it had in its domain are going to be brought in with it. Okay? Think about bringing someone into your family. Any issues that they have, they bring with them. Same with f of g. So, any domain restrictions will have a consequence later in f of g. So the domain of g will restrict the domain of f of g. So, we're going to do this now with functions instead of just tables and graphs. And what I'm going to do is take one function and put it into the other one. When I do, we're going to find its domain. So there are a couple of steps here. You might want to write these down. First, we're going to find the domain restrictions of g. In other words, the one that we are plugging in. Okay? So g is the one going into f, so we find its domain restrictions. Then, we're going to go ahead and find the composition f of g. You're going to simplify it down, make it nice and pretty, and then find the domain restrictions of f of g. So you found the domain restrictions for g, now find the domain restrictions for f of g. We are going to write our domain with both restrictions. Okay? So this is how this is going to happen. We're just going to take these 4 steps. We're not going to panic. Here we go. Here we go. Let's start here. I have these 2 functions. Let's go up here. F is x squared plus 1 and g is x minus 3. Nice, nice, nice. If I want to find f of g and its domain restrictions, its domain, I'm going to take the g function and put it into the f function. Take x minus 3, he's going in here for x. That means f of g is the quantity x minus 3 squared plus 1. Now, I want to simplify that. So this is, make a box, x minus 3, multiply it out. I have x squared minus 6x plus 9 plus 1. Let's simplify one more time, make it nice and pretty. There it is. This is f of g. Now, let's go figure out our domain. When we look at the one we were plugging in, g, x minus 3, does it have a radical? No. Does it have a denominator? No. So it does not have a domain restriction. This is a line, guys. It goes from negative infinity to infinity. Okay? So no domain restriction there. When I come over here to f of g, excuse me, does it have a radical? No. Does it have a denominator? No. So it does not have a problem. And so this is a parabola, and again, it goes negative infinity to infinity for its domain. So the domain of the composition is negative infinity to infinity, or all real numbers. Alright, for f of f, boy, I sure don't know how they have you type that on Pearson, now that I'm thinking about it. We'll have to figure that out. F of f, what does that mean? That means take the f function, plug it into the f function. Let's do that. I'm going to take this whole thing and putting it back in here. You see that? The whole thing goes back into this x. So I have x squared plus 1, quantity squared plus 1. Hit pause and think about what just happened there if you need to. I'm going to multiply this out. It is a box. This is x to the 4th plus 2x squared plus 1 plus another 1. So final answer, x to the 4th plus 2x squared plus 2. Domain time, here we go. The function I plugged in, f. Does it have a radical? No. Does it have a denominator? No. So does it have a domain restriction? No, it's all real numbers. When I come over here to x to the 4th plus 2x squared plus 2, does it have a radical? No. Does it have a denominator? No. Does it have a domain restriction then? No. This is a pretty polynomial. X to the 4th, it's going to end up, right? It's going to look like a W, okay? Or it looks like a parabola sometimes. This one probably looks like a parabola. So no domain restrictions, so negative infinity to infinity. Miss Noble, you said this was going to be hard. Those are linear and quadratic functions. They're so pretty. Let's do the next one. I have f of x equals the square root of x plus 4. G of x is 2 plus 3x. Here goes. Let's go find f of g. That means g into the f. G into the f. So I have the square root of 2 plus 3x, oh brother, there we go, plus 4. Can I simplify this a bit? Yeah, let's go ahead and simplify it. So I'm going to add the 2 and 4 together. I have 6 plus 3x. Nice. So for f of g, I'm going to take the g function and look at its domain. For the domain of g, does it have a radical? No. Does it have a denominator? No. So its domain is all real numbers. For f of g, does it have a radical? Yes. What do we do with radicals? Rip out the guts, set them greater than or equal to 0. Solve for x. So I have 3x greater than or equal to negative 6, which means x is no flipping. I'm dividing by 3. Greater than or equal to 2, negative 2. So the domain restriction here, none. This one, oh, it's got to be greater than or equal to negative 2. In Pearson, it probably writes it this way. I also enjoy this way. Okay? All right, g of f. For g of f, the f function is going into the g function. This whole thing is going here. Up here. Oh boy, here we go. G of f. 2 plus 3 times the square root of x plus 4. I just replaced x with the square root of x plus 4. Can I simplify this? No. The 3 is multiplied by the square root. You do not add these together. Multiplication over addition. That's done. Let's go figure out the domain. So I find the domain restrictions for f. Does it have one? Yes. It's a radical, so I rip out its guts, set them greater than or equal to 0, and I solve. No flipping of signs. I did not divide by a negative. This is the domain then for f. When I look at g of f, does it have a radical? Yes. To find the domain restriction, rip out its guts, greater than or equal to 0. We just did that. This then is the domain for the whole thing. That was the only domain restriction. So I'm going to write it this way also, because that's pretty. All right, we have one more to go. You're excited. Look at that. We love fraction fun. F of x is 3 over x minus 1. G of x is 2 over x. All right, we're going to go find f of g. That means I take the g, plug it into the f. So for f of g, I'm going to do 3 over 2 over x minus 1. Now I want to give you a little secret. Okay? This is the short version of this story. Usually takes us a little bit more time to ponder this. If I have a fraction inside of a fraction, and I want to clean this up and make it pretty, we don't like this going on. To clean it up, I'm going to multiply everything, because the top and the bottom, by this denominator that's causing all the trouble. So everybody gets multiplied by x. Okay, that's the short version. So when I multiply the numerator by x, I have 3x. When I take 2 over x times x, I get 2. When I take 1 times x, I get negative x. There we are. Let's go figure out domain restrictions. Let's think. G has a domain restriction, 2 over x. Does it have a radical? No. It has a denominator. The denominator can't be 0. So what number makes it 0? 0. Silly. Can't use 0. Go to f of g. Look at the denominator. What number is going to make that equal to 0? By the way, if you're not sure, just take it, set it equal to 0, and solve. Okay? The number that makes it equal to 0? 2. In Pearson, they have you type it this way, but you know I think that's ugly. So I'm going to write it this way. There he is. Pretty as a picture. Any of these numbers will be just fine in here. Alright, g of f. Now we're having fun. The f function goes into the g function. The f function goes into the g function. So, 2 over 3 over x minus 1. Do we like that? No. It has a fraction in the fraction. So I'm going to multiply everything, top and bottom, by the denominator that's causing all the ruckus, the x minus 1. So I take this times x minus 1. I take this times x minus 1. So what happens when I take 2 times x minus 1? I get 2x minus 2. Did you get 2x minus 2? Well, yeah, you can distribute, right? Alright, on the bottom. What happens when I take 3 over x minus 1 times x minus 1? Shazam, they cancel out, it's 3. There's your g of f. Let's go find the domain. I need a domain restriction for f. Let's look at f. Does it have a radical? Does it have a denominator? What is its domain restriction? 1. X cannot equal 1. When I look at the composition, does it have a radical? Does it have a denominator? What number would make the denominator equal to 0? Nothing. There's nothing that's going to make 3 equal 0, so that it does not have a domain restriction. It's actually just 2/3 x minus 2/3. Don't worry about it. Alright, so this one I could also write it as this, interval notation, and that would be delightful. You made it. You did it. That is a tough section. You might want to go back and re-watch this. When you are doing your assignment on Pearson, you might need to hit similar problem and try to get a better score. Okay? Don't settle for 30%. That means you didn't learn anything. That means you're going to fail your next quiz. Go back and redo. Alright. Good luck. Come see me at the chats.